All right, here we are again, once again Tuesday night with the Hangout presentations. We got Sven here. He's going to talk about his DCC operation with RC equipped um, system that he came up with. It's pretty interesting. My camera's not wanting to focus in here, right? But anyways, we're going to have Sven going to do a presentation on that tonight. I've been asking him a lot of questions, and I think some other people have been asking him questions. And we'll go ahead and hand it over to Sven. If anybody has any questions, just type in the Q&A there, and we'll get started. So here is Sven Frank from Germany.
Hi there, good evening. So, dude talked me into this because he saw me operating my little micro layout with this thing, which is just a standard 40 megahertz radio control, which I had in use anyway because of this little model sitting up there, which is radio controlled. So, and before I started building this layout, I bought a DC locomotive, and I need some sort of a DC throttle to test run it and to test run my track work. And I thought, well, it's just parts with modulated control, so I might as well just use this RC system for that. And I hooked it up, and it works just fine. So this is basically just a DC throttle using radio control. Now, let me pull up my screen share here. There we go. Hopefully you can see that all. So this is my current system with 40 megahertz radio control. I go a little bit over the options for expansion and sound that I have using this system. The next chapter is the Delton 2.4 gigahertz system. That's a British company that has small handheld throttles and onboard receivers. Also battery power and dead rail or cold rail, as it is now called. And the last chapter, I will go over the Tam Valley Depot radio control system for DCC.
That route heater no longer having to put it all down.
So, this is basically my setup that I use currently. Yeah, Mike?
Yeah, I'm sorry, I don't mean to interrupt. I hope it's okay if I just, because I know you're going to go into this, but I want to try and understand, because I've done RC airplanes, so I've used a lot of this equipment. I'm curious though, is this equipment specific for model railroading, or is this the same thing that I'd be using in my RC airplanes?
The system I'm currently using is the same thing as for RC planes.
Okay.
In my case, it's 40 megahertz, so everything that crawls around the ground or floats in the water. Yeah, for airplanes, it's a different frequency. It's 35 megahertz up here in Europe. I think the States has some different laws on what can be used for airplanes. But it's basically the same, yeah.
Now, Sven, I see that you're using a frequency on that one there. Can you use... because now they've got, it's called DSM. Can you use that system as well? Because DSM is like a satellite frequency or a cell phone frequency. It picks up the the available frequency, and it locks it on that. You don't have to use an actual frequency chip like what you've got in the illustration there.
Yeah, that's correct. That would be the 2.4 gigahertz systems. And the system itself is the same, just the communication between transmitter and receiver is done in the 2.4 gigahertz frequency range. And you have the lock-on process, the binding between receiver and transmitter.
Okay.
That makes the difference. Everything else stays the same.
I have a question too. Can you convert this to Wi-Fi and use, say, an Android phone or so to run it?
No, not this system.
Well,
You can do what you're wanting to do, though, Bill, by using JMRI.
Run an Android through JMRI?
I believe so. Isn't that right, guys? Using JMRI, you can set this up with applications to be able to run it through your Android phone. Is that what they're doing?
Yes.
Yeah, there's an application on Android for JMRI called what is it, Local Throttle or Engine Driver or something like that for Android, and one for iPhone as well. And JMRI has some plugins and components for radio control, so I don't think it would be out of the question to take what Sven's presenting and bring that to JMRI and then have the other throttle parts.
But that's not for cold rail, though, battery-powered cold rail.
Not necessarily, but JMRI, there's a plugin for some radio control functionality in there with JMRI to where JMRI can control anything you can hook to it. So it's not out of the question. It's not something that's being standardized or used a whole lot with JMRI, but there has been some talk in one of the forums about bringing radio in, and fundamentally JMRI would support it, even though it's probably not an out-of-the-box configuration. I don't think it's too far-fetched to take what Sven's presenting and get it to JMRI with some work.
Okay.
Yeah, I think with the DCC system from Tam Valley Depot, which is the last chapter of this presentation, you can do that with the JMRI and Y-throttle or any other application to run off a smartphone throttle. So this is coming a little bit later in this presentation. All right, so back to this little schematic. So this is my throttle side, standard transmitter, and on the layout side, at the current moment, I use a receiver, a motor controller, and instead of hooking up the motor controller to the motor itself, I hook it up to the track. And this way I can run one DC locomotive picking up its power and its commands through the rails. Quite simple. As I said, it's just like a DC throttle, with the only difference is this is portable and wireless. So not connected via cable to the layout itself. And for my layout and also for the large layout I've planned for a living room, I don't need much more than this. I just use one throttle for one locomotive. It's a switching layout, but I need to have the ability to walk around with the throttle and work in different locations and switch different industries along the line. Yeah, since this whole layout is about 22 feet long, having such a long cable dragging behind me from the main plug to the layout and then out to the different locations would be not really fun. So moving on from there, what do we have optional available to do a little bit more than just controlling the train? I have an expansion module built into the throttle in this position up there. That's called a 12 plus 2, 12 because of 12 switch functions and 2 proportional functions, which is a level control. So it's a little potentiometer, and wherever I set it, the servo goes in that position and stays there. So it doesn't recenter itself like it would do with those joysticks. Those are self-centering, they always go back into neutral once I let go.
Even for the throttle one?
On the layout side, yeah. I can convert those joysticks by taking out the spring underneath in the mechanism. And then those joysticks would stay in position. I push them in, and once I let go, the joystick stays there. So, and on the layout side, this is the also called decoder. Since this module uses one channel of the 8 available on this transmitter, I need to have a decoder plugged into the matching channel on the receiver. And on this side, I have my 12 outputs and my 2 servo channels. So what can I do with that? I could go ahead and switch light functions, crossing gates, handle a stationary sound unit, like a Pricom Design Dream Player, which is triggered by push buttons. And to get the sound out and not having it in one place, I'll simply go ahead and hook up wireless headphones and carry the sound with me while I'm walking along on the layout. So everything stated that happens is right on my ears, and I don't bother the neighbors or everybody else in the room.
Nice.
How this thing can be technically hooked up would be something like this. So I still got my receiver sitting up here. I got my multi-switch decoder that gets a feed of 12 volt from the main power supply. And in order to switch larger current loads, like a bunch of street lights, a bunch of building lights and stuff like that, I implement relays in between. So the decoder just switches the relays, and the relays trigger street lights, building lights, crossing flashes, flares, whatever is built to the layout.
Sven,
and I got the sound module. Yeah.
I just want to try and clarify this Rogue multi-decoder that you're showing here. Is that the main part that is allowing you to do this through your railroad, or I'm not real clear what this Rogue multi-decoder is.
It's basically a multi-switch. So I'm using one channel of the transmitter. I have 8 available. Each joystick is 2 channels, one for forward and back, one for left and right. Yeah, I guess twice, so this is already 4 channels used for the joysticks. And I got those expansion module places up there and there, where I can put those units in. And those use one channel, but sending out a decoded signal for 12 switching and 2 proportional signals. And on the other side, the receiver receives that signal, sends it out to the decoder. The decoder converts it back to a switching signal, which is basically 0 volt or 12 volts between those output pins.
But how does that single channel from that receiver, how does it determine, because that just like what you're saying, from the receiver, the Robe Futaba FPR118F that you have there, when are you showing this Robe multi-decoder plugged into that receiver? Is that what you're showing there?
Yeah.
And it's plugged into a single channel, right?
Yeah, that's correct. The first 4 channels on the receiver, that black box, are used for the joysticks. Yeah, that's channel 1 to 4. It's all just joysticks.
Okay, and that's like throttle and a few other things. I don't.
Yeah,
what I don't understand is when you activate. It looks like you've got this into maybe channel 5 or 6. I can't tell. But when you activate that channel through your transmitter, it receives it on the receiver. Then you only have like I don't know. I'm assuming it's variable, right? So you have different positions for that channel, like you do with the servo that's plugged into there. How do you determine what you're doing there? It's all from just the switches that you're adding to your transmitter.
Yeah, that's this is a whole circuit board. This is not only switches. There's a lot of SMD surface mount components on the backside.
Hey, Sven.
And those modules. Yeah.
How many channels are you running on that radio, on the transmitter?
At the moment, I use for the truck. I use 6. So the 4 on the joysticks, 1 for this 12+2 expansion module, and I got another 12-position rotary switch, which deals with the sound module.
Okay, I think I can answer Mike's confused question there. You're running on what frequency? You said 40.
That's standard 40 megahertz, like back in the day, since the 50s and 60s.
Yeah, that's old for here too. Okay, on your transmitters, Mike, if you have 12 channels and you're running 40 megahertz, that 40 megahertz has, how would you say, a rider of multiple frequencies, and they're split in micros off of that 40 megahertz. So if you have 12 channels, your receiver's picking up all these small little micro frequencies off of that 40 megahertz.
Okay, that's way over my head. I just know flying airplanes, what I plug into a receiver is a servo, and that servo can have like, it's like however many positions. And I guess the question is that how the switches work? Is they, that he has on his, what is it, his, on the transmitter, the little switches. So when he switches one of these, or Sven, when you switch one, does it just like send the same signal that it would send to a servo, but just a very specific position or something? I'm thinking servo, and I'm trying to understand how so many functions can come through a single channel from that receiver.
That's the thing. When you're adding more functions to your transmitter, you're splitting each function into a micro rider of that 40 megahertz. It's like 40 megahertz, 0.01, 0.02, 0.03 that operates each individual servo. And his multi-decoder is plugging into one of the servo slots. You're used to plug and play. Now this is all broke down.
Yeah. Well, I guess the question really is that unit that's plugged into that receiver in slot number 5, is it receiving data from that receiver exactly the same way as it would be receiving for a servo? And if
Yes.
so, okay, so realistically what it's doing is kind of like what a stepper motor would do then. It's say, okay, if it gets to this position, or if it's at this position, then do this. If it's at this position, do this. If it's at this position, do this. So that's basically what that's doing, right?
Exactly.
Okay, perfect. All right,
Go
thank
ahead,
you.
Sven. Finish it off.
Sorry, Sven.
All right, no problem. So, yeah, as I was already down here. Okay, so I got my receiver, I got the multi-switch decoder, and each output, which is always 2 on each slot. I have my 12-volt positive in the middle, and the output, the outsides are negative, and those get switched on and off. Yeah, like a toggle switch, but only remote control. So, and as I hook up relays, just to prevent too heavy of a current load to this decoder. It says high current, but I can only hook up about 1 amp of current flowing through this whole unit, so including the servos and everything else hooked up to it. So just to prevent it from burning or an overload, I use relays.
So Sven, it would be really easy. It would be real easy for something like Chris is using the RC servos for his turnouts. You could use one of those frequency or one of those channels on the receiver to control his turnouts, couldn't he?
Yeah, but with servo control, with multiple servos, I would go with an expansion module with 8 of those little potentiometers. Yeah, there's 3 different option modules available. This one, the 12+2, which has both. Then you got a 16 switch module. So this would be 8 switches. Each switch has 2 positions, gives you 16 switching functions. And there's another one out. This has only 8 of those potentiometers. That would be 8 proportional channels. So you control 8 servos with 1 module, and each transmitter module has its matching decoder module that goes with it. They don't come in a set, so you gotta buy them separate.
Yeah, you can add your multi-decoders into other slots for your other functions, such as plugging in the servos.
Yeah, that's correct.
Right.
But I can only install 3 additional expansion modules in this transmitter. So I got 1 spot over here, 1 spot over there, and underneath this F14 sticker, there's another slot where one of those modules would fit in. So
or you could build a side box and mount everything.
No, that's everything that this transmitter can support.
Okay.
So now, once I've hooked up all my switching functions, I can also hook up a Dream Player, for example, as a sound module for ambient sound, like city sounds, crossing gate, the bell sounds, industry sounds. and I use one channel to control an engine sound module. That engine sound module is stationary on the layout, hooked up to, in this case, channel 5, because it's the only one left available. And to choose different sounds from a start-stop sequence for the prime mover, bell, horn, etc., I use a 12-pin rotary switch and a trigger switch, which then would start those pre-selected sounds. And in order to get the engine sound plus the ambient sounds out to my headphones, I'll plug it into a Dream Mixer and can adjust the output levels of either prime mover and the ambient sounds to have it relatively level and pleasing to my ears.
Hey, Sven.
That's pretty much everything that I can do with this system. It's all based on picking up all the commands from the rails for the locomotive. Everything else is stationary on the layout, doesn't move at all. And I carry the sound with me only with headphones. Go ahead, Mike.
Yeah, I just wanted to say, I posted in the chat here. We have 10 people in here, and how much I really wanted to say. I'm gonna drop out so another user or member of the community can come in. So I just wanted to let you know that I'm not bailing on your thing. I'm gonna watch it on TV though. So hopefully, dude can relay to the community that there's an opening so somebody else could join. Okay.
All right, Mike.
Thanks, Mikey.
Yeah.
All right. Have we got any more questions to this system?
Well, I think, I don't know, but I think Chris had one. I saw his mic turn off for a second, and I didn't know if he had a question or when I asked about the servos that he uses on his layout, you know, so.
Yeah, I was a little bit curious about that. I already have a system in place, but I'm going to be adding more, and I need to buy more things. So, is there a way? It looks like those switches go on your remote, but is there a way to mount them like on a fascia or anything remotely?
As I said, this works all over radio control, and the way the transmitter and receiver communicates is all pulse width modulated. So if you set up your servos and try to find the center position of the servo itself, the mechanical center position, you use a small a servo tester, I think.
Yeah.
Yeah, with either push buttons or a small potentiometer.
Yeah, I'm using the Tam Valley system, and it comes with what they call a remote aligner, so you can center it with that.
Yeah, and this little circuit board, the aligner is imitating the signal that the servo would receive from either a receiver or those multi-decoders with its servo outputs. So it's a pulsed voltage depending on the position of the potentiometer.
Okay. Well, if you get caught up on what you wanted to do and you're looking for something to fill some time, I'd like to know more about your Pricom, the Dream Player and things like that. If you get to that point tonight, looking to fill some time, I'd love to hear about that.
Yeah, the Dream Player, I can briefly talk about that at this point, since we are already at the sound. The Dream Player itself, it's a WAV file or CD quality audio player. Yeah, the same thing basically as an MP3 player, but a much higher quality. As I said, it's a CD quality output. All the sounds are stored on a little SD card. This is this little slot down here. It's a micro SD card, which means you can record whatever you want yourself, or pick sounds from the internet, or drag them from a CD, put them onto this SD card, and play them back. The playback itself, the Dream Player Lite can have 4 different sounds, but only play back 1 at a time. And their standard Dream Player, I think it's MK2 at the moment, can play back all 4 sounds simultaneously. And to trigger the sounds, you have either push button, or you got a trigger sitting in between the rails, yeah, like a red or a light detector that would close the contact between one negative and matching to the sound position on this board. And output is a 3.5mm stereo jack, where you can either hook up active PC speakers, or in this case you can go to Mixer, which is an active mixing console. So it requires 12-volt power supply and mixes all the sounds active and puts them out through a 3.5mm stereo jack.
Do you need an amplifier, or how big of speakers can you drive? What's the output on that? Like for under layout speakers?
I don't have the technical data on screen at the moment, but I think those small speakers can be hooked up direct. It definitely drives already built-in amplified computer speakers. Yeah, those are active. Or you can hook it up to a home stereo system if you do.
Okay, so
that's
it's
the wall shake.
So it's pretty much just a line level output that needs to be amplified for speakers.
Yeah, it all depends a little bit on the size of the speaker and the current and voltage that's needed to drive the speaker itself. Yeah, those little ones we use in our locomotives, or the small ones from a phone, it can drive this without, or those without having an amplifier in between it.
Okay.
It all depends on what you want to do. What is your application? Some brake squeal underneath the layout. You might not want to have this too loud.
Yeah, I'm just looking for like in the mountains, you know, just kind of the diesel rumble as it's echoing off the hills going through the mountains. Add some more bass where the the HO scale speakers are very lacking in the bass area, and just to kind of get that reverb through the mountain effect, you know, just something playing under the layout as it's passing through that area. That's what I'm looking at.
Yeah, I think Andy is dabbling with those ideas too, having on the layout speakers in certain areas to play back some sounds like brake squeal and squeal of wheels in tight corners.
Yeah, and I am using multiple of the Procom boards to do it, and I'm doing the same thing you're doing as well. So I'm going to have a couple subwoofer type. I mean, they're still small speakers, but say 4-inch drivers is what I have right now. I'm experimenting with for creating that deep bassy rumble sound, and I'm using those just under the layout as more ambient room sound, like a subwoofer would be in a surround sound. And then for wheel squeal noise, right now I have some little 1-inch by, they're roughly 1-inch by 1/2 inch small speakers that I'm putting under track for wheel squeal noise, because I want that very low volume and very close to the track. But if all you're looking for is that rumble, I've downloaded some audio files from the internet and just played them just through a subwoofer, and it's pretty hard to tell where that sound's coming from. So you could get away with just a couple speakers in your room, and you would probably get that effect. And one Procom board or a couple Procom boards, at worst case, would play back that sound.
Okay. Yeah, that's exactly what I'm looking for. And the flange squeal too. I'm going to be having a big curved trestle, and it squeals constantly going over that. And I'd like to replicate that too.
And that's the hardest one to replicate from what I've done so far. So I have some example sounds, and they are, high frequency sound that don't seem to travel very well. So for my personal experience, my early experimentation led me to believe I needed to put that sound as close to the track, or, not ambient room, but very close to the track. So I'm right now experimenting with using a speaker every 3, 4, 5 feet, something in that neighborhood, as close to the track as possible. In my case, I'm mounting it under the roadbed, but I'm also going to use those Procom boards and trigger them in some way. Right now, I'm just electrically triggering them with the Procom switcher board and just triggering the relays. But I think what Sven was talking about was like using the optical sensors, so that you could use whatever control mechanism you wanted, battery power, remote control, whatever, and then that sound effect would just happen when there was a device there that blocked the light. I personally am probably going to use block occupancy for that.
Yeah, I plan on doing that, tying into whatever I use for my signal system.
Me too. And I'm going to do fairly small blocks of occupancy detection, so that automation is really good, but also sound is good. So right now, my current experimentation has led me to believe that I'm going to isolate the track every 3 feet and just isolate every section of flex track.
Sven, Log and Local has a question, or it's not really a question over there in the group chat.
Well, I do have a question. I mean, it's related to what I typed. Sven, have you tried using Bluetooth, or do you think you could plug into a laptop or something like that, or to a computer, and send the audio signal, patch it through Bluetooth, and have Bluetooth speakers embedded?
I haven't really experimented with that or really thought about that. Yeah, as I said, I came up with this idea to have this all mounted on the layout itself. It's all nicely wired up, and I don't have to move anything around, and the only thing I carry with me is wireless headphones.
And are they Bluetooth wireless, or?
I think the new ones are now Bluetooth. There's a couple of, I think it's 466 megahertz or something like that, still on radio frequencies.
Yeah, so yours are based on radio frequencies.
The sound is, yeah,
because,
the sound for those home stereo headphones
is a good option.
Yeah, I need to try this out and test this. There's a few Bluetooth devices for either your smartphone, have it sit on the table, and via Bluetooth is playing back the music on some external speakers. and those devices not always work that well. You have a lag in there, and sometimes dropouts
Yeah.
for whatever reason. Yeah.
Well, you're limited to 33 feet anyway
So,
with Bluetooth at most.
yeah.
And it's heavily compressed audio, and I've experimented a little bit with Bluetooth using JMRI's virtual sound decoder, playing sound back to determine if I like the idea of sending sound to speakers, much like Sven is doing. And I personally use Bluetooth a lot for, listening to music, and I'm using Bluetooth right now, the headset to talk to you. But for the railroad room, I've not had very good luck at using Bluetooth for anything so far.
Like, my only thought was, these days you can find a lot of Bluetooth speakers, and they're becoming dime a dozen. And so, and they're becoming very compact. And you could pick up a bunch of Bluetooth speakers and, use some control mechanism to, like you said, Andy, you'd have, speakers every 4 or 5 feet. And these days, the Bluetooth speakers tend to give a nice bass boost, too. So you don't get just the high pitch that you get from the engines alone.
And I found some that were 2 inches by 2 inch little square Bluetooth speakers that I thought I could mount under the track and use those. And I even initially thought that I could pair them all up with a computer and use some switching software to switch from Bluetooth to Bluetooth to Bluetooth speaker as I went down the road. But as I got multiple devices, and I even initially started messing with Apple's iBeacon technology, which is also based on Bluetooth, to do proximity detection of locomotives to know which speaker to fire. And I bought a couple iBeacons and started playing with that. But I've not had the best success in very small proximity. So on a couple 3 feet range, it doesn't seem to be accurate enough. So I think I decided to use block occupancy for the control and triggering. But I'm not against buying those Bluetooth speakers and taking them apart and hardwiring them.
Yeah, that was the other thing. You could take the small speakers and hardwire them. And then the other thing is, if you get really sophisticated, you could have upcoming speakers on lower volume until the engine approaches closer and the volume increases to add another layer of sophistication to it and decreases the power.
I haven't had very good luck with volume control and ramp up so far. So right now, my current experimentation is kind of an all or nothing, and my hope is that with the sound volume fairly low, that when a locomotive is firing, say 3, 4, 5 speakers down the line, that one speaker just going off and another speaker coming on will not be a significant distraction. But I'm still in experimentation.
Or reverb.
Yeah.
Problem I've had with Bluetooth is picking up harmonic frequencies from the layout itself.
And Bluetooth has a lot of latency, especially when you get interference. So if you had, 10, let alone 50 Bluetooth speakers, the level of interference, which produces latency, would cause some out of sync and problem areas. So in my personal case, I'm siding with Sven and favoring hardwiring for the sound, at least for the sound components. And I'm all in favor of the wireless hand control like what he's using. I think, of course, that's perfect to be able to walk with your train. But in my experience, wired speakers have proven to be much more adept at what I'm doing.
Yeah, I would agree.
Fluorescent light frequencies plays havoc with almost everything that you run electronically.
Yeah, you got to stay clear of fluorescent and go with LED or something like what GM's got. Those are not bad. Or Pricom has an LED system that also ties to the Pricom soundboards and other Pricom components. It's a single system that's cohesive across the Pricom chain using Prinet.
Exactly.
Right, and on top of that, you got wireless network on the home, typically, and cordless handsets also interfering.
Well, let's not get off of our subject here.
All right, moving on from the old school 40 megahertz radio control system to a little bit more recent technology. Also, this system is probably 6 years on the market now. And this is the Delta 2.4 gigahertz radio control system. the large-scale garden railroaders and the narrow-gauge ON3, ON30 guys love this stuff. This is a little bit of an overview of a transmitter. That little black box, the size of a cigarette box. And this locomotive down here, the huge one, is HO scale, N scale, N scale, N scale, and a couple of components for size comparison. Yeah, this little board is a receiver, a motor controller, and a light board, all in one. So it means you need one of these and one of those batteries to fit into the locomotive, and you're good to go without wiring up your track. So this is 2.4 gigahertz, radio control, battery powered.
Okay.
Yeah, go ahead.
No, you answered my question. Basically, the locomotive runs off the battery, not the rail.
Correct. Correct.
Okay,
and
now I have a
using
question.
40 megahertz. Yeah.
How do you fit 14 to 16 volt battery in an N scale steam locomotive?
This system can run off of 7.4 volts, which is a 2-cell battery.
The system can, but the engine can't.
I've done a test run with my HO scale GB40 and supplied it with only 6.97 volts, and let it run here on my little test layout, and the engine hasn't any problem at all.
No, I'm not saying
It's
problems. I'm just
a little
saying
bit
how do you
slower,
get-
and
I'm not saying problems. I'm just saying how can you get the voltage, enough voltage into an N-scale steam locomotive to have it run at a decent speed? 7 volts is only going to make that thing creep.
as I said, I've tested it with my HO scale GP40. I had it run on 12 volts to get an idea what is Vmax, and then I switched down the power supply to 6.97 volts and run it again at full speed. And the speed differential isn't that big. It's
Right.
maybe 25% less.
Yes, Sven, you're not getting my question. My question is the battery size. To get a battery to give you 12 to 14 or 14 to 16 volt, where do you get those? Now you got to remember N-scale steam.
As I said, you need only a 2-cell battery, which gives you 7.4 volts overall, which is enough
Watch batteries?
to run this lithium polymer batteries, 2 cells.
Watch size batteries.
No, those are basically the same as used in your modern day cell phone.
Don't have room for it.
Yeah, so how do you fit that in an N-scale locomotive?
That's what I want to know.
In the boiler, for example.
That's where the motor and gears are.
Maybe the tender?
Yeah, or a tender.
Too small.
A tender is a possible way. And if the engine is absolute tiny and nothing really fits in there, maybe the receiver itself, yeah, this little circuit board that might fit under the roof of the cab, and you hook up a ghost car, a box car, permanently connected to the locomotive, which carries a battery and is connected via 2 wires up to the locomotive.
Hmm.
Yeah, and in HO scale, you have pretty much no problem at all to fit those components. They're getting smaller and smaller.
Okay.
I know that the 2-cell batteries. I get those little microplanes, and the microplanes come with a. It's like that one battery above the round that looks like a AA or something like that. Those microplane batteries for those are 7.5 volts and 500 milliamp, and they're really small. They would probably fit, somewhere on a like in the tender or something, because they're really small. They're only maybe the ones that I had were maybe 3/4 of an inch long and maybe less than a half an inch wide, and you can put those in the airplanes, and some of the airplanes in those microplanes probably have about the same size motor as a N-scale has, and you could probably I could get 12 minutes of flight time out of one of those batteries. Now on a train pulling a load, I don't know,
Yeah.
And the other, I guess you could also, in the same vein, use batteries from your point-and-shoot cameras. They're getting smaller.
Yeah.
Or MP3 players, tiny MP3 players.
I mean, they're
about 3.5 volts.
Well, the batteries in cell phones are even getting smaller too.
And they typically run about 1,200 milliamps, and at about 3.5 volts.
Yeah, and
your milliamp is what is your power as far as longevity is, and if you're in milliamps, you don't have the running time you would normally have.
No, you wouldn't.
Because like the battery I'm seeing here on the picture says 3.7 volts, 600 milliamps hours, right?
Yeah.
And so I can't see a train running with that for a long time.
Nope.
I see a huge draw from the engine, especially on startups and pulls.
The folks that run those systems and even run those systems in with small batteries, where I thought, okay, you get 15 minutes out of this and that's about it. In ON3, those little locomotives run 45 minutes on a battery which has 180 milliamps capacity. And I thought,
wow,
oh, that's a lot.
Well, I was talking to some G-scale guys at a train show one year, and they run all of their stuff on the same thing that you got, RC setups. And I go, so what you guys are using, like a 4 or a 6-cell battery to run those G-scales? And he pulls a battery out, and the battery is only a 2-cell and maybe 3 inches long by, and it blew me away. And he says, yeah, we can run anywhere from 30 to 40 minutes pulling 20 cars. And I'm like, are you kidding me? And he says, well, a lot of the G scales that they're doing, they're converting the motors over to a
CAN motor.
Well, they're a brushless motor, and
right.
They get a lot more runtime out of them.
Not only that, though, but those batteries, if you look at them, they run anything from 6 to 12 volt each.
Yeah.
And they're lithium. But see, the thing is, now I've got a G-scale big hauler, which is radio controlled, battery radio control. Now that run, I can put, let me see, it's 246, just 9 volt, and I can run that thing for about 2.5 hours on the 9 volts before I have to pull it and recharge. But
wow.
That's a large size engine. Now I could take my N-scale steam engine and stick it in the tender of that thing, I'd love to have a radio control setup for N-scale with cold rail, but you know, I don't think it's going to be possible with the size of batteries.
I think the technology is going to get better and better. I know that just like you, Bill, you're in RC, and so was I. I can remember back in the day when RC cars, electric 10 scale with brush motors, were running. They would barely get 5 minutes of runtime out of the batteries back then. Now with these 2-cell batteries, with the one that he has in that picture right there, that's a 2-cell LiPo battery,
Right.
and some of the 10 scale guys are getting 35, 40 minutes of runtime out of those batteries because they're brushless motors. So I could see people converting N-scale to have a dry rail, converting an N-scale with a brushless motor, and I mean, I think it's possible. I really do. I think that the technology is getting better and better,
The only problem with that is I may not live long enough to see.
Yeah, true. Go ahead, Sven.
This technology has come a long way only in the last couple of years. So this is a small British manufacturer. They provide transmitters and all those different types of receivers in different sizes with different numbers of outputs. Yeah, depending on what you want to control and how much you want to control on this particular engine. The batteries getting better and better and smaller. Yeah, if I go over here to this sheet, this is a battery that you would normally find in a cell phone. You can buy those online. This is a size in millimeters, so 30. It's a little over an inch by a little less than an inch wide. So, and I could get 2 of those into a fuel cell of an GP40 locomotive.
Yeah. I just don't like running it.
The little receiver already wired up to connect to your motor and to the battery. Yeah, and that's all that needs to be added to the locomotive. 1 of those, 2 of those batteries, and you're good to go.
There is a write-up here in the Q&A from TC Car. The smallest battery will fit a 3-cell in a set N-scale. I don't know what he meant by that. I don't know if he's done it or what. But plus he's asking how to get in. If you're a Google Plus member, the link to this is on the YouTube Model Builders site on Google Plus. You have to be a member of Google Plus YouTube Model Builders to get the link, because we put it there just so that we don't get a lot of unregistered users of non-model railroaders in there, TC Car. So if you go to Google Plus and the YouTube Model Builders community, you will see the link there to get into the show if you would like to do that. Go ahead, Sven. Sorry, I didn't want to interrupt you there.
No problem, no problem. Okay, so as I said, this is receiver already wired up for placing it into a locomotive. 2 of those batteries, and that's about it for the locomotive side. And as for throttles, this is a single locomotive throttle, or can communicate with 1 receiver at a time, and only 1. Yeah, you get your speed control up here, direction switch is up here, this toggle switch. There's 2 push buttons. One is on/off for transmitter itself. The other one is the bind button, where it's needed to connect the receiver with its transmitter. And this potentiometer up here is, I think they call it inertia, which is like momentum on a DCC decoder. Yeah, so you have instant access to your momentum by just turning the knob either up or down. So if we go to this transmitter, that's the largest one available, has a few buttons more. Obviously speed and direction and inertia, as I said, like momentum on DCC systems. Bind and on and off, and this selector switch. And there it gets a little bit more interesting for multiple locomotives. Selector is a 12-position rotary switch, and you can bind 12 locomotives, so meaning 12 different receivers, each one to each switch position. So the one locomotive that's selected at a time receives commands from this throttle. So you choose your direction and your speed, send the locomotive on the way, and you grab your selector switch, choose the next locomotive, and the first one you send on the way will continue doing what you told it to do before you choose the next locomotive. So you can send one out on the mainline run.
If you have the speed set halfway for locomotive set in selector position 1, and you turn it to selector position 4, and that speed is at halfway, would not locomotive 2 and 3 and then 4 automatically be throttled to full speed, or is that speed adjustment knob does it not have an absolute stop and an absolute full, or how does that work with selection? Because it seems like you would be turning a bunch of locomotives on as you went through the selector switch.
No, since you got your direction and speed already off center for the first locomotive, the next locomotive would only start to do something when you set your direction to center, so which means off, and your speed back to 0. Then select a direction and set your speed, and then the locomotive starts picking up and really listening to that throttle.
Wonderful, very smart.
So each selector dedicates to that particular engine.
Yeah, you get position 1, and position 1 is connected to locomotive number 1. Position 2 is the second locomotive. Position 3, third locomotive.
Mm-hmm.
This binding process happens every time you switch the locomotives and your throttle on. So once you kill the power, if you switch the throttle off by accident whilst the trains are moving, so you have a total signal loss, all locomotives will immediately stop. Yeah, and you need to reconnect and rebind to every receiver that is in bind mode, which means switching the locomotive off, switching it back on, wait a few seconds before the receiver is in bind mode, select your selector switch position you want this locomotive to be on, press the bind button. Once it's connected, you're good to go to select the next receiver, select the next position on your rotary switch, and so on. Yeah.
Yeah, it's just like emergency stop on a DCC.
Yeah, just in case something happens with signal loss, those little receivers have all the files they've built in. They will just immediately stop and do nothing until they get a clean signal. Yeah, also if you go out of range, range indoors is somewhat between 50 and 100 feet, which is decent. And if you go accidentally out of reach, get your throttle in the pocket and leave the basement, go out of the house, the trains will just stop.
Yeah, I've lost a few airplanes like that.
Yeah. To prevent this from happening or any other accidents on the railroad, yeah, this is a nice built-in fail-safe.
In RC language, we call that a runaway.
No, we call that stupidity.
Yeah.
Watch where you're going, Fred.
Yeah. You know, it's not to change the subject, but you know, since we're on all this frequency stuff, I could remember back in the day when somebody would turn a radio on and they'd be on the same frequency as somebody else, and you want to talk about a runaway, you know. But when electric 8-scale started coming out, an electric all-wheel or a 4-wheel drive electric 8-scale buggy, when it has a runaway, it don't matter if it's upside down or upright, it still moves because the tires grow so big that it don't matter which side it's up. It's still going to move, and everybody just gets out of the way and waits until either the speed control burns up or the battery dead.
Yeah.
Yeah, or it hits something serious.
Well, that's why we now have flags and clothespins.
Yeah. Go ahead, Sven.
Yeah. All right. So, is there any questions to this system currently appearing on the chat or on the panel?
I don't see nothing not too many questions in the Q&A tonight. That's surprising.
Well, then let's move on to the real interesting stuff for most of the railroaders, the Tam Valley Depot system, which surprisingly enough not too many people use, since this is absolutely easy and not really too expensive. The basic system setup is like this. Instead of hooking your bus line from your command station to your bus via cable, you hook up this little antenna and transmitter module that replaces your bus line, and the locomotive gets as an add-on to the DCC decoder that it already has installed, this little receiver module. Has 3 wires, 2 for its power supply from the battery, yes, and 1 for a DCC signal, which gets hooked up to the DC decoder. And obviously, to feed some power into the locomotive, we are again with the batteries. So that would enable you to run an unwired, completely unwired layout.
So would you be,
maybe for
Sven? Would you be able to
occupancy detection? Yeah, go ahead.
I'm sorry. Would you be able to program it just like that locomotive? You know, because the nice thing about that is you're only going to go. It's only going to go to the one locomotive that you want to use. So would you be able to program that locomotive in the same manner?
Yeah, the only thing that changes is the way the locomotive receives its commands. Yeah, it's not picking up the DCC commands through the rails and the power pickups built in the locomotive via the wheel sets.
Okay.
It's getting the same signal it got before through the rails, through the air.
I talked
Nothing
to.
else changes.
You can actually program this just right through the wire. I talked to Duncan, who makes these, over email, and he says you can even power this with the Sprague Nano, which means you don't have to have a command station if you don't want one. Just your computer.
Yeah, everything that's DCC signal. As I said, everything that's DCC signal gets transponded via this transmitter to the receiver module. It doesn't matter which command system it is. As far as I know, there may be some exceptions for some strange systems. I don't know. Yeah, but the major manufacturers, Digitrax, NCE, Lens.
Very unique.
So that's yeah. I don't know why this system isn't really visible on more layouts. It's fairly affordable. We're talking about somewhat around $70 for the transmitter, which you buy one, and around $70 for a receiver module, which obviously you need for each locomotive.
Hey Sven, can any of these run on DC?
Yeah.
So you could pull the power off the track?
As I said, this just replaces DCC, and I haven't any information if that can replace DC. I don't think so.
And the RF module,
if you want to run,
I assume hooks onto a DCC decoder.
If you want to run DC,
it actually has 4 wires. There's a white wire there too.
Is it okay? Yeah, then it's a signal, and yeah, you're correct. It's power, and the signal is, I believe, 2 wires, and obviously the antenna. Yeah.
Yeah.
So what you're saying is you could run it DCC with the antenna plugged into the command station, and then have the wires hooked up to where you could run DC off the rail, right?
Yeah, that's what I'm asking. You know, could you pull power instead of the battery from the DC? Because you're not taking, you know.
If you disconnect, if you disconnect all the power pickups from your DCC locomotives, yeah, so that they don't accidentally get some DC power into their systems. Yeah, just remove the wires that come up from the trucks for all the DCC locomotives to be on the safe side.
Well, you just want to disconnect the decoder, right? You still want the pickups if you want to go DC.
No, since you run on batteries.
No, I'm saying if you didn't want to run off a battery, could you hook it up to run off the track and bypass the decoder altogether?
That would be possible, to hook up DC as a permanent 12-volt power source, and then run those DCC systems without installing batteries. But you still have the problem with having to clean the rails.
Sure.
And having everything correct, isolated, and you got your reverse switches by, if you run a loop, a reverse loop, you still need to change polarity, and in order to get rid of all of those, that was the idea behind it, to put batteries and a DCC capable receiver in there.
Right.
To get rid of all of those electronics. And
if you could pick up power from the rails, you could, solve for the N scale issue.
For N scale, that would be an idea, but as I said, it still would bring up a lot of wiring to the layout itself. Which you have anyway. If you run a large layout with automation and block detection, you still need to create your blocks and isolated sections, and either block occupancy detection through resistance, right? Or All right, now let me end. So I'm pretty much through with what I have to present. If there's any questions, go right ahead.
Sven, could you, in a couple of words, summarize what the benefits versus some of the issues that come up with the system are? The positives and the negatives?
The DCC system, on having that wireless, as I said, you don't need to work with bus lines. You don't necessarily need isolated sections, take care of reverse loops, having issues with frog juices or anything else. It's completely, you just throw your track down, have it mechanically work nice and smooth, and once that's done, you set up your locomotive and go, and don't care about wiring and shorting out track and something like that. That's the benefit of it. Obviously, you're limited in running time, depends on how large your batteries are, what you can fit in as a battery on board or with a slug engine behind it, a dummy engine just there to carry your batteries, which would enable you to put in 11.4 volts, what is it, somewhat 1 amp capacity. That lets you run, pretty sure it's about 2 hours of running time.
Now, when you say
decent for an operating system.
When you say 2 hours of runtime, let's say, how many rolling stock would that be? I mean, how many rolling stock would you be able to handle if you did convert over to battery power? I mean, because the more load you put on the locomotive, the more power it's going to draw out of the battery, right, Sven?
Yeah, that's correct. I'm thinking about somewhat around 20 pieces of rolling stock, and the grades somewhat around 2%. Yeah, obviously, if you go with 4% grades and tight curves and try to squeeze those long trains up there, that is drawing a lot of current. Yeah, but you're not running all the time. There's phases where you stop. What was that?
At that point, you're adding more engines with more batteries in them.
Yeah, that would be an option, yeah, to extend the amount of batteries, or just switch out the slug engine, take one out, plug it, put it to a charging terminal and set up the next one with a fresh battery in it and continue. Yeah,
Now
that
you
would
got
be
the
an option.
opportunity for operation switching and such.
Yeah, but you still need to touch the locomotive physically by connecting the MU cables,
Right.
which then carry the power over from the slug
Basically,
engine
that's
up
the
to.
connector. Yeah.
Yeah, it's just to bring the power over from the battery to the locomotive. Everything else, the locomotive could run on its own.
Can you charge off the track? So could you take the track power and hook it to a charging circuit on this? So would it be possible to have some section of your layout have voltage on the rails just for the purpose of charging, maybe under a water and cooling tower? So
that was going to be my next one. How do you charge the batteries?
Most model railroads that use battery power take their engines off the layout and charge them separately. If you hook up a track with power from your charging terminal, if you flip the engine around, you have reverse polarity. If you don't have any reverse polarity protection circuits in there, you'll blow up your battery.
Yeah, you'd probably have to set it in one direction
Since you
each time.
charge it backwards.
Yeah, unidirection pickup.
Yeah, either you'll be very careful, or you will have a nice campfire in the basement.
Get the hot dogs.
TC Carr says there's a station. Stanton makes a board for that.
They call it a battery power supply. It's both a upcharge thing, ups the voltage from a single cell, which would also solve some of your in-scale problems, and it charges it from the track if you need to.
Yeah, I was thinking about the in Germany there, the big layout with the trucks. When the batteries go low on their trucks that's on the highway, they go into a docking station and recharge the batteries. I was thinking about that same thing.
yeah, I mean you could wire staging tracks to have power on your staging tracks, so everything's charging when you're, and that's the only section of the layout you have to run wires to, and that's also a section of the layout it's not hard to hide wires in. So.
Yeah, but you have to pull the train in the same direction each time so you don't reverse the polarity.
Yeah, I thought about that. Or you could use a reversing switch, the way we used to have to build reverse loop switches on DC circuits for a loop or a Y. And if your train was facing forward into the bay, you would flip that switch this way. And if it was facing aft, you'd do it the other way. But that brings up my biggest question that I was going to wait through all this RC stuff to ask was about consisting. So that especially becomes a problem if you have several F units in different directions on one staging track and wanted to charge them. That may not be possible at all.
Use a diode bridge. Diode bridge will correct the incoming current to be correct for your electronics. You don't care then if it's AC on the track, DC on the track, positive on right or left. You really don't care.
So just a couple of diodes in each locomotive, and you could charge, you could pull into staging, and if there happened to be power there, then it would charge the batteries while it was in staging.
Yeah, it only go one way through a diode.
Yeah, that's a smart idea.
Well, that's why you use a bridge, because then you got diodes. A bridge is made to convert AC to DC. In this case, we're using it like they do in a telephone. You can't wire it backwards.
Right.
Because
it's
it will correct
no
matter what way you put the feed to it.
Yeah.
Whatever you put in the bridge will come out the bridge the correct way.
And if you put charging on staging, then the life expectancy of the batteries becomes less of a concern, and the only life expectancy you need is how long it takes you to go from staging through the operation of the railroad back to staging. If the batteries will last that long, you've got all you need.
Well, that was the other point, Andy. You know, now you have extra switching opportunities and operational opportunities on the track.
Like we need more of those.
No, but equipment changing is a very valid operational consideration, and just so because it happens to do with batteries, we just hide that as another operational consideration, and
Yeah.
steam locomotives run out of coal, run out of water, diesel locomotives run out of fuel, so we'll just treat when the battery gets low as they're out of water or what have you.
The coal bunker.
Make your charging stations inside your roundhouse.
Oh yeah, I like that too, and that's why the first thing I mentioned was if you put a charging station under a water tank or a coal loading facility. So I mean, and I don't think most of these batteries charge fairly quickly, or at least pick up some charge fairly quickly. So if you pulled in under the coal tower for, I mean, how long does it take to charge, Sven? 10, 15 minutes? Would that pick up enough charge to be significant?
It depends a little bit on the battery itself. If you shop for lithium polymer batteries, it will tell you in the product description something like 12C behind the capacity. And if it says 12C, you can charge it with 12 times its capacity. So by taking 300 milliamps capacity, if you set your charger to 300 milliamps output while charging, it will take you an hour. Or you can set it up 12 times as high, and you would only need 1/12 of 1 hour to recharge the batteries. The thing is that those batteries get hot if you quick charge them.
Yeah, that's about 5 minutes.
So I wouldn't recommend it. But
yeah.
Hey, Sven,
if you're in a hurry,
there is one other thing too with LiPo cell batteries. There is a minimum amount of voltage that they can draw down to. If you go under that, they kind of have a tendency to self-destruct too. I mean, we found that out with RC cars. You've got to have a minimum volt regulator so that the voltage gets down so far, and then you've got to charge them, because we found out that if you let that voltage get too low, they will actually overheat and catch fire as well too. So
battery protection circuit prevents that.
Yeah,
exactly. Yes.
A little better voltage, under voltage protection.
Yeah.
Usually it's under voltage, over voltage, and over current protection, and you can build them into each battery if you want to.
Now, one other question, Sven, is how would you, let's say if you want to do a consist, how do you consist in one of these systems?
In my 40 megahertz system, it doesn't work at all. In the 2.4 gigahertz system, the Delta system, it doesn't work at all. But on the Tam Valley DCC system, this radio control system, nothing of the functionality of DCC changes, just the way the throttle communicates with the locomotive.
Oh, okay.
And obviously the power pickup. Yeah. So consisting is like you used to do it.
You could consist in those other systems, but it would be a permanent consist. You'd have to set up an AB, ABA, or ABBA F unit set, or a set of locomotives, and MU them together so that battery power and control would go between it. But it would be effectively a permanent consist.
I got a question.
Like we did on DC back
and not on the 2.4 gigahertz, because you can only bind one receiver to the transmitter. In standard 40 megahertz DCC, in standard 40 megahertz systems, I can take two receivers and equip them with the same set of crystals. And they would both listen to the same commands coming from my transmitter. So I could technically, if I put everything on board of the locomotive, consist two locomotives.
Yeah, that's
by using the same crystal in both receivers.
That's what I did on my F-14 jet. It was running 2 of the Dutch jet engines. Had to have 2 receivers. Just match the crystals. But getting back on those batteries, we used to use the LiPos, but the chargers had all that extra stuff built into it, so you wouldn't get an overcharge. And the battery itself, we always stopped before it got to the bottom, but they'll take a memory. If you keep them going too low all the time, they'll take a memory.
Yes, they will.
Start to get too warm, we throw them up in the refrigerator or the freezer for a little bit and cool them down.
Go ahead, TC.
Yeah, actually looks like somebody named Almar was next. Yeah.
Oh, go ahead, Al.
Yeah, he had a question.
Yeah, I completely forgot about you, Al. Go ahead, Al.
That's okay. Although intriguing and interesting, what I just got into DCC, so what would be the cost effectiveness to get into doing all this? You know, I'm running on cold track and instead of going with the DCC.
I can answer that. Have you bought your DCC?
Go ahead.
Yet? Have you bought your DCC system yet?
Yes, I have.
Okay, well, you've got that expense, but you could always sell it. I don't know if you're planning on using JMRI or using your computer for any of this stuff.
I'm not sure yet. Probably not.
Okay, then. You would hook up either Stanton or whatever. You're going to hook your output to the little transmitter, okay? And then on the receiver side, you're either going to use the Tam Valley or the Stanton or the converter, or believe it or not, NCI just came out with one that's got the transmitter built into the decoder. So you're either going to use one of these little adapters, and those depend on what you're trying to do, how much power you need, naturally, as to how much they cost. But that is just a cost increase. The decrease is you don't have to wire your layout. But if you're using your DCC to run switches and everything else, it starts to get more ambiguous.
Well, the thing is, I bought the system. I bought 3 DCC locos. So now I'm into this right now for $1,200 just to get started. And, you know, how would I convert a DCC loco with sound to run on DC?
You mean to run on radio?
Yeah, to run on radio.
Well, you basically have to hardwire it. You're going to either disconnect your rails or use it as a battery pickup only. Then you got to have a battery in there, and you got to have the receiver, and your decoder actually. If you go with the Stanton system, it comes all pre-assembled. You got to buy it only from them. The other guys, you have to take the output of the receiver and feed that to your decoder as if it was the rails. So nothing else changes. All your wiring on your locomotive internally, except for that, it's the same. Unless I know something I don't.
Well, I'm assuming that the power input from the trucks to the decoder would be the difference?
Yeah, you're going to feed that to the receiver instead.
Right, from the battery.
The battery goes to the receiver.
Right, but that would come off where the trucks are.
Yeah, either way, you don't have to use a battery. You can use track power if you got track power. But then you're not really, except unless you're using the battery strictly as a big, super huge gap get acrosser. The battery and the transmission doesn't. If you've already got everything wired for DCC, it could be argued whether or not this would be any advantage. If you've already spent all that money and done all the wiring.
I haven't done any wiring yet. I'm just starting the layout. I just got back into it after a lot of years.
Then if you don't really want to run the wiring and clean your track all the time, the transmitter and multiple receivers for each locomotive compared to the cost and time of wiring?
Actually, you can. I heard a good argument by Joe Fugate arguing about the cost of this stuff. He equated the cost of frog juicers for switches, even though he had a wired layout, versus buying keep alives or battery or radio system. And the cost was cheaper for him to buy keep alive circuits for each locomotive than to do frog juicers for the switches. So you can weigh that cost out, and especially with the Tam Valley system where, and correct me if I'm wrong, Sven, but it's an entirely additive system. You just add that one radio module to your existing DCC equipped locomotives, and you immediately have radio communication of DCC signal. You get all the other features. You get to use the DCC system that you purchased and all the functionality with it. You just get the ability to not depend on perfect track and perfect wiring to get your signal through to the locomotive. And compare the cost of adding those radio modules with Tam Valley to the cost of frog juicers for switches, let alone layout wiring that you haven't done yet. I think you'll probably come out cheaper with the Tam Valley system than you would by doing all the layout wiring and switch frog juicers and all this other stuff. So
that's what I'm a little bit not understanding is because of, I mean, it's not the material. The material I already have. It's not that the thing of purchasing the material. It's, you know, and then what happens if your loco stops halfway somewhere, and then what do you got to do to get it back?
And as I said, I bring this screen up again. You buy this transmitter once. This is one time around about $70. That's your transmitter module. Hooks up to the command station, whatever one you have. And on the locomotive side, it's $70 roundabout for the Tam Valley Depot system. I don't know the prices of the other ones. For each DCC equipped locomotive, this is an add-on. And if you want to go with battery power, which makes the most sense just to get rid of all the wiring and wiring issues, those batteries per cell round about $7, so $14 for a battery. Those were the additional costs, and you obviously need to squeeze this thing and two batteries into one locomotive to get it going.
I don't know how this would work for anyone, but Duncan equipped one of his ON30 locomotives with a two-cell 7.2 140 milliamp hour battery pack, and he ran for about an hour and a half with just the locomotive. So you don't have to have a big battery or a lot of power. You don't have to have 16, 15, whatever volts. As far as cost, I'm bringing that up. I just got some notes. The converter from CVP is about $100, I think. And then Tam Valley has another high power version. It's a little bit more power. But you don't have to use those unless you're doing larger scales like O scale or bigger. Like I said, the Stanton system works a little bit differently. They hardwire the receiver into the decoder, and then the batteries feed directly to the decoder, so that it doesn't, the receiver doesn't care what kind of power load you're trying to load, or what, you know, you got to modify the decoder a little bit, and that's permanent. But anyway, you got to buy the whole thing from them at that point. Their battery power supply is kind of nice. They sell that separate. They want $20 a pop for batteries. They're supposed to be really good batteries, but that seems kind of high.
You know, there's a manufacturer, you're talking about batteries, There's a manufacturer that takes all the mismatch cell batteries from all the major manufacturers. It's the same exact batteries that all the big high-dollar manufacturers make their batteries out. They take the mismatch batteries and match them and make sets out of them, and they're, believe it or not, they're really, really cheap. And they're just as good as the high-dollar batteries. A lot of people will disagree with me on that, but all the the years that I was running LiPo batteries in 10-scale cars, shoot, I never had I was able to run 3 years on one battery, So.
Well, and we don't require the power drain that the flying guys use. You can use a lower sea level and a longer charging time, and it's much safer than some of the quick turnarounds that these guys do. Especially if you make sure you got a protection circuit or a multi-cell, a balancing circuit, whatever you need to make sure you're safe with your batteries. If you got a bigger scale, you can go with the, what do they call them, lithium ferrite or whatever they're called. They're not as adaptable. I don't remember what they call them, but a little different chemical, a little bit lower voltage, but they're safer. But then you can't fold them around inside your locomotive to make them fit places. They're a little bigger too. I haven't tried that yet.
I think the concept is great, but for the normal modeler that's a lot of actual work to do. Maybe I'm wrong, because like I say, I'm just getting back into it. But by the time you buy the radio, the receiver, these boards that go with it, and everything else. I mean, I know people that are in RCs. I used to be into it a long time ago. You're going to pay $400 for a good, remote control unit, just for the radio and the receiver itself.
You do have a point. It's one of those things that it gets more variety of guys. Let's say somebody comes from RC and they come in and they want to start like me. I mean, I was in trains before I was in RC. And if I was into flying helicopters or airplanes, which I never was, we had, for RC, you've got a stick steer style radio, not a joey stick, like a lot of the Europeans use. But anyways, it just gives, Al, it just gives a more variety for guys to look at. It's it's not something that like if you wanted my opinion, I would say, Al, stick with what you got, because you're more familiar with that. It's just one of those things, like TC there. It sounds like he's pretty familiar with this newer system that's Sven that's talked about. But it's just more variety. It's one of those things that. If someone wants to get into it, and the way I look at it is price-wise, the scale can go either direction, like what Andy said. It's just more variety. It gives more ideas. If you don't want to have to mess with wiring out your layout, you don't want to mess with. Look at Keep Alive systems that are starting to step up. Yeah, look at Andy there, or Bill there. He's showing that there's like really ancient. That Challenger 620 that's an old radio,
Oh no, I do understand it, and I really thank Sven for the presentation. It was really educational, but cost effective for
Thank you.
How many people were on and how many. I know some of the people, but not all of them. It was just, I was just trying to, where do you draw the line? Is the track that bad that, I'm going to be laying 350 feet of track. Is it going to be that much of a nightmare?
No, Go ahead, TC.
In my opinion, go ahead.
I was going to say it can be, but that depends on how you do your track and how you clean up, how you keep it clean and so forth. I'm in a wheelchair, so for me, bending over and cleaning up track and things like that is kind of like one of the reasons I'm interested in this, because it would drive me nuts.
Yeah,
No,
well, I believe the
understandable.
live circuits are absolutely critical for my operation with hand-laid track and all the details I want, and it allows weathering to a level that is not, right now we weather track in a way that allows good electrical conductivity. But if we can go to battery circuits, and I'm absolutely going to keep alive at a minimum, then we can also weather track to a level of realism that not permitted because of electrical conductivity.
That radio I just showed, that's for my live steam #1 gauge.
I believe the concept is really good. There's things I don't like. What happens when your train starts to die? You have to get it to a charging place. If not, you have to physically move it, or do you liven up power to the track to charge the battery? There's a lot of things, and then everything you have to buy to do it. A radio, if you don't have it, which a lot of you guys were in RC.
Right, Troy.
Well, that was the whole reason I asked Sven for the pluses and the minuses. And also, I guess, when I think about binding and the loss of binding, having to rebind every engine, that might also pose another issue, while during operations or running the engines. So that's another consideration. And I think you have to sort of assess it. Is it something, fits your need? Like Andy mentioned his need, and I think TC mentioned his need. So you sort of, I would say just assess your needs. And if you've already invested inside of a DCC, then that's the route you ought to proceed.
But for Sven, for example, and for a whole lot of other people, if you have a small layout or a switching layout, or you're going to run solo locomotives, or you have a logging layout or something of that, like the system that Sven is actually running on his layout couldn't be more perfect. No wiring, nothing else to do, just add a module to his locomotive, stick a battery in there, and you're not investing in DCC, and that can be a reasonably large commitment for an even basic system. I think that's his first and second systems he offered are perfect for small layout owners who haven't already bought another system. The Tam Valley system, I wasn't putting serious consideration in, but after this presentation, I'm going to do a little more research, but I'm about sold on going with the Tam Valley solution. It sounds, it's a win-win-win.
That's a good system.
It's compelling. I mean, you get all the advantages of DCC. You get JRMI, which absolutely I want to run JRMI. And I was going to use keep alive circuits anyway, and it lets us be lazy and do poor track cleaning, or not have to keep track of it all the time, and keep good sound. The keep alive circuit, even for good track cleaning, good wiring, frog juicers on turnouts, do everything you want to perfectly. It's still hard to get perfectly consistent sound on locomotives, so the keep alive circuits are kind of a no-brainer. But if I can spend a little bit more money and have the Tam Valley component, I don't have a keep alive circuit that just keeps it doing what I last told it to, but I have radio control. It's really compelling, Sven. It's been a good presentation so far.
Yeah, I mean, it certainly makes a compelling case that if you haven't set up anything and you're building your layout from the ground up, and you haven't invested or have an existing system, that it eliminates your whole wiring need, practically. Except for something like you talked about, Andy, of a charging station.
Yeah,
Sure,
switches
you can add
would be
staging.
the only thing.
Oh, don't get me wrong. I never said it was a bad presentation, please.
No, we know that, Al.
I really enjoyed it. I've watched Sven a lot of nights build his own stuff. I watched him build his own throws, his ground throws. He knows what he's doing. I just, the comprehension's a little bit. I'm not really. I mean, I think it's a great idea, but the change from what I already have now, or just starting now, I'm sorry.
Well, and that's why the Tam Valley system,
Al,
I think,
you
makes
still
the
have
most sense.
the possibility.
Go ahead, Sven.
You still can switch onto radio control later on. Yeah, it's an additional system. It's the additional transmitter and the additional receivers, which you can decide on buying those and putting them into locomotives later. Yeah. You don't lose too much money. Obviously, you lose the money spent on the wiring on the layout itself. Yeah. Other than that, it's all fine. Yeah?
Well, the wire didn't cost me anything, so.
Well, all in all, I think it was a really good presentation. I think that I'm glad I brought Sven in to do this presentation. It was funny when I asked him to do it because he just kind of looked at me with this look on his face of, oh boy, what have I done, you know? But anyways,
yeah, if I wasted anybody's time, blame it on him.
So you know, I want everybody to thank Sven. I think everybody in the Hangouts have watched Sven working on his little module layout that he's got there. And when I saw him with a you know, an RC controller, I was like, what is he using that for? Because you know, I was never aware of any of that, you know, until I saw him operating it. It's just some research that I never did, you know. But
gosh darn it, he threw another twist in the whole thing.
Yeah, he
did.
Exactly. You got that right.
So you know, I'd like all of us to thank Sven for coming on and doing this presentation. Of course, I'm going to hit him up to do probably a few more, and just to let everybody know, he is one of our new team members for the YouTube Model Builders team.
Congrats,
and so he's going to be, I think he's our graphics designer.
Yep.
And that's another thing that he's really good at is he has a section on his layout where I had to ask him how he did that, and he just took a picture of it and he had to modify it in a Photoshop program to change it a little bit. But you know, I like the way he did it, you know, and you know, I want to thank everybody for coming into this presentation, and you know, like TC, glad to, you know, have you in here, and it sounds like that you know these systems pretty good too. It sounds like it's something that you use on your layouts.
Well, the layout isn't built yet, but yes.
Cool.
I did post the name of the Dead Rail Society, which is a Yahoo group, but we now have a web page. DeadRailSociety.com. Yeah, that's my kid. My other railroad nut. So Sven, can you draw a straight line?
I can draw a straight line, yeah. I think so, at least with a ruler.
Exactly. Exactly.
Yeah, I've used radio control for the a lot of people call it G gauge, but it's #1 gauge for about 12 years now. And so the concept's not new to me, but like I said, trying to get that kind of thing into an N scale, I'm still got that rattling around in my brain.
Well, you know, like I said, I eventually want to do a G scale, and that was one of my questions. I ran into some G scale guys, and they told me about the radio system, but it was, you know, it's a little different what they were using than what Sven was using. And
No,
of course,
I'm using the regular radio. That transmitter I showed you is what I use.
yeah. Well, they had a square box, just like one of the ones that Sven had posted up there that he presented, you know. And of course, the LiPo batteries, they convert all the cars over to you know, CAN motors or LiPo or brushless motors, and but you know, because I want to run mine out in the, you know, I want to get a snow plow and plow the snow out in the yard. And
Yeah.
you can't do that if you put power to the rails, you're going to have issues. You
Well,
know?
I see. We don't run power. This is all live steam, so
Oh, true. That's
big difference. You talk about cold rail. It's freezing rail when you get it out in the snow.
Yeah, no kidding.
Well, are you going to call it cold rail or dead rail, or dead as in electrically dead?
It used to be called dead rail, but the terminology has changed in the last year and a half. You're now calling it cold rail.
Why?
Because when you consider electricity and it's hot, so you have hot rail.
Well, okay, I was an electrician before I was injured. We called it live or dead. When it called the hot and the cold are two different wires of a live circuit.
Yep.
Yeah,
so,
true.
If it's alive, it has a hot, a cold, and a neutral. Maybe.
110.
110 only has a hot and a neutral.
Yeah. We call it hot and cold.
Three-phase has a cold wire. So, one of the companies doing large scale called CVP is doing the smaller scales now. That was that little converter I mentioned. They're a little bit more money, but they will run, say, an O-scale locomotive or one of the toy train locomotives because they put out a little bit more power.
Well, once again, I want to thank everybody for coming in and joining the panel tonight. You know, it was a good presentation. It gives another avenue for guys to look at, and that's why I brought Sven into it, because you know, it just it's something new that I saw. Just like Al, he saw that it was new, and I think that's the reason why he wanted to come on and see what it was all about. And anyways, I want to wrap this presentation up for tonight, and once again, I want to thank Sven for coming in, and everybody else, and
No problem.
so
thank you, Sven. Very informative.
So
thank you.
I want to thank everybody.